Good afternoon, everyone. Hope you enjoyed lunch. Do I have something on my screen yet? No. Welcome in this session, Architectural Patterns for the Cloud. This is going to mainly cover Windows Azure. Who of you has been using Windows Azure before? Okay, who has heard about Windows Azure? Who has no clue of what Windows Azure is? Okay, good. The idea is to give you a quick overview of Windows Azure first, just to make sure you know all the latest components, because a lot of them have been added over the past. They are not covered in every session that you will see on Windows Azure, so just quickly going to cover that one. After that, we'll dive into a scenario which we are going to migrate from a traditional data center to Windows Azure. And just, I'm going to give you an insight of what can happen in Windows Azure. Because, okay, it's cloud computing, it's high available, but you should modify your application to use that. Things I'm not going to cover is general architectural guidance. I'm just going to cover one scenario. Why am I not covering all possible scenarios? Because that's just way too much for 1 hour session. So I'm just going to stick with one scenario. My name is Maarten Balliauw from Belgium. I have my flight in 2 hours, so I hope I can make my flight back again. I work for Real Dolmen, which is a company in Belgium doing all kinds of IT consultancy. I focus mainly on web and Windows Azure, but also on NuGet, on which I co-authored a book. So if you're interested, feel free to sponsor me. I blog on those topics on my blog, and on Twitter you will also see me announcing stuff that Microsoft releases on web, on Azure, stuff like that. So the agenda, as I said, a quick recap of what Windows Azure is. Then I'm going to cover all the differences between what you have in your own data center or on Amazon or on whatever other cloud provider and Windows Azure. We're also going to rethink an existing application, and then I hope we can reach a conclusion on all those things. So a quick recap on Windows Azure. It's a cloud platform, which means it's an on-demand thing. You have to go to a website and ask for a service, which also means it's self-service. If you don't self-service your application, if you don't deploy your own application, it will not work. You won't even have a VM running there without having an application. You pay per use, which means you pay for storage, you pay for compute, you pay for traffic between all those things, you pay for transactions, you pay for a lot of things. There's a lot of variables there. And it's highly automated. Which means there's typically no humans involved. So if you deploy your application, it's an automated process that will take your application, deploy it to a set of VMs, which will make sure you have a storage account which you can use in your application. There's no humans involved, typically. Windows Azure has a couple of components. Typically, they give you an overview. You have compute, you have storage, you have all those other services. I like to think of it a little bit different. You have a set of application services, a set of stuff that you will typically use in any application, which includes, of course, compute, a service where you can host your application, where you have a virtual machine on which you can host your application, run your business processes, things like that. You have BI there. Typically, every application has some reporting services component or something like that. Those are all services hosting your application. Next, you have storage services. Of course, any application requires some sort of persistent storage. And that storage can be all the storage accounts that Microsoft Windows Azure has to offer, blob storage, table storage, queue storage. There's also SQL Azure, which is a service similar to SQL Server, where you can host your data in a relational way, where you have queries, where you have views, where you have stored procedures, all that kind of stuff. And there's the content delivery network, which is just an extension on top of the storage that you can leverage to, well, basically do two things. One is make your service faster. The content delivery network will make sure your storage is spread across the globe into, I think, 26 different data centers. So if you store a file on storage and enable CDN, it will be available in all those data centers. Another option for using CDN is if you have a high traffic website. Typically, the storage account will only serve up to 500 requests per second. If you have CDN, that will be a way higher number. So you can just enable CDN, not just for geographically distributing your data, but also to make your site faster and make it able to handle more requests on the storage account. And then there's a number of foundation services, stuff you use to integrate with other services. There's the service bus, which you can use to communicate between your service on Azure and a service sitting in your own data center, or between two clouds, or between two data centers, just using the cloud to have them communicate. There's ACS. What if you require your Active Directory logins for your cloud application? What if you have a cloud application on which users should be able to log in using their Active Directory credentials? There's ACS to do that. There's a caching layer. You probably don't want to keep everything sitting in storage. You probably want to have some sort of caching in your application, and that's where this caching layer comes in. It enables you to have a distributed cache for all your services running in Windows Azure. So that's a lot of components, and all those components actually provide some differences with your typical data center you have in-house, or your typical Amazon deployment, or your typical deployment at some hoster somewhere. There's differences with your infrastructure. Azure is a uniform system, which means you cannot customize your operating system. There's only one operating system available currently, and that's Windows. One specific version of Windows, eventually with some patches applied, but it's just Windows. You cannot customize the VM. Well, you can customize it, but it's a bit harder to do. It's automated. Probably your own data center still has sysadmins running around. Windows Azure, of course, has them as well, but you are not exposed to them. The only thing you can do to manage your application on Windows Azure is use the automated services. Also, Azure is designed for failure. I know most data centers should have some redundancy in there, and they should have 2 power outlets and 2 network connections and stuff like that. But Windows Azure is really designed for failure. And if you don't think about that when building your application may suffer from the fact that Windows Azure is built for failure. It's also designed for scale. There's a lot of components in Windows Azure which enable you to scale out, scale up. You can have a caching layer, you can have distributed caching, you can have workers sitting in the back do some CQRS style approach. It's designed for scale. But the most important difference is it's not in your data center. It's not something you manage, it's something Microsoft manages, and you don't have access to the servers, you don't have access to, well, basically anything that is not exposed through an API or through the automation Windows Azure offers you. Uniform. By that I mean every machine is approximately the same. You have Windows running there. You have no specialized hardware if you require a virtual machine that has a better GPU to do graphical calculations or something like that. That's currently not available. All machines are exactly the same. You choose a small instance with a certain number of CPU, certain number of memory. You choose a medium one, you choose an extra large one, whatever you want, but there's just a few types that you can use, nothing in between. There's also just 2 operating system versions available today. Windows Server 2008 and Windows Server 2008 R2, which means if you really require Windows 2000, you have a problem. If you really want to upload your customized VM, well, you can do that today on the VM role, but still you lose a lot of the benefits from Windows Azure. So remember, Windows Azure is just uniform. You're not able to customize a lot of your machine. You can customize some things. I told you about the fact that you can select your operating system version. I'm going to quickly show you that in my Visual Studio. I don't know if you're aware, but your service configuration file enables you to select OS family 1 or 2, which means 2008 or 2008 R2. And also enables you to specify the specific OS version, which is just an identifier to give you an idea of which patches are applied to the service. If you look on MSDN, you will find all those versions explained there, which hotfixes are in there, but basically that's the choice you have on Windows Azure today. So no custom VMs, not something that is really tailored to your application or to your existing applications. Another thing you can do to customize your VM is in your service definition, you can add a set of startup tasks. For example, this one is a startup task I added which installs ASP.NET MVC in my server. just making it available in my global assembly cache on Windows Azure. But it's a manual step I have to do and something that happens every time when I boot a new machine on Windows Azure. So it's not a customized VM. I'm just changing the startup of this VM to make sure some components are available in there. And what I can do in there is basically just write a batch script which, for example, installs ASP.NET MVC through the web platform installer on Windows Azure. But it's not a customized VM. It's still the same VM, just with a different startup in which I install something. Other differences. Windows Azure is pretty automated. Let me quickly go there. Windows Azure is the one making decisions on where to provision your application, on when your server requires an update, on whenever health issues occurred. When your application does something weird, Windows Azure decides if it's healthy or not healthy. And the platform knows what's best. Problem is, in your data center, you probably know, by monitoring your application and eventually automating something, you probably know what's best for your applications. In Windows Azure, the platform does the same thing, but the platform ensures that the platform is healthy, not necessarily your application, which is a major difference in architecting your applications. For example, if you have a high CPU load and your servers start to hang, what it will do is just provision a new VM, copy your application, and make sure it starts again. If that was a long-running process in one of those servers, that server is gone and the process has no output. So it's a difference with your own data center. Azure is also designed for failure, which means there's a network load balancer. They have a set of fault domains in which your VMs are provisioned. So imagine this scenario where you have 8 VMs. What Windows Azure will do is spread those VMs across different fault domains. And what those fault domains are, those are just different locations in the data center. A different rack, a different power circuit, a different network connection, just to make sure if any of these things go down, your application will still survive in the other fault domains. So if one fault domain crashes, you just lose some machines, but not all of your machines, which is also something you should consider checking for your architecture. If you architect your application for Windows Azure, you should make sure that something like this can occur and you can immediately lose 1/3 or 1/5 of your servers because of a failure in the data center, for example. Know that this can happen. There's also something different, which are the update domains. You see the horizontal stuff? Whenever Windows Azure updates the operating system, when they apply new patches, for example, what they will do is go through these update domains. They will, don't have an animation in there, they will bring down one update domain. So in this case, that will be 6 servers in this example. They will just bring down one update domain across all those fault domains, just to make sure whenever a fault domain crashes, you still have some servers running, even during an update. You should also consider that this can happen. You can lose a lot of machines in your architecture. Make sure you cover these situations. Updates happen all the time. Every few weeks there's a new update, unless, of course, you specify a specific version. It will not update, but if you don't, if you just leave the asterisk in there in the configuration file, it will update your application. So this can happen. And failures, unfortunately, happen as well. Last week they had an issue where something like this happened, so prepare for that. In your own data center, you prepare for your application to survive, and you can modify the data center to support the application to survive. Windows Azure just monitors Windows Azure. It will make sure there's still VMs running with your application on it, but if you don't think about that up front, your application may suffer from situations like this. Windows Azure is also built for scale, and not for scale up, just go to higher machines. It's built for scale out, which means they have standards, they have a load balancer. If you have multiple VMs, the load balancer will balance all the traffic between all those VMs in a round-robin way, which means your application should be stateless, or you should think about managing state somehow different. For example, put your session state in the cache layer and use that to share the session state between all the machines. But if you don't know this, if you don't think about the fact that Windows Azure is stateless, you may see some interesting problems with your applications once you deploy it. Another interesting difference is it's not your data center. You cannot manage your application, your data center environment, but it's also difficult to integrate. If, for example, there's some reason where your application requires your Active Directory, or a local SQL server, or a local WCF service, or something like that, you have to think about a means of integrating both the cloud and your local data center running some application that you still have in there. So think about that. Think about how you will integrate Active Directory, how you will integrate some WCF services, some REST services, and so on. Think about how you're going to do that. The platform has components to fix all this, but you have to think about it. Now, what we'll do in the rest of the session is rethink one application. I have a nice application here, a newspaper website, which is a typical scenario that you may see. Just a website that's available both national. Users from Finland can go to this website. Users from across the globe can go to this website. There may be sudden spikes in usage. For example, if something interesting happens, a lot of people will try to read this newspaper website. And there's a combination of dynamic content and static content, which means all the text, all the banners, those are generated based on which user is browsing the website, what day it is, what data is available in the database. But there's also a lot of static content. Typically, any website you look at is about 80% static content, which is just images, CSS files, JavaScript files, and stuff like that. So just a typical website like you would build them today. The architecture of this thing is pretty easy. Let's imagine it's currently running in a data center that has a load balancer, which does virtualization. They have 2 or 3 or 4 or some VMs running, and they use a SQL server in the backend. Again, a typical application, which you can just migrate to the cloud or which you can build in the cloud from scratch. You can just create some VMs there, use the load balancer of Windows Azure. You can host your database on SQL Azure. It will work perfectly, but it may fail. It may fail big. Reason for that is there's a lot of single points of failures. There's a lot of stuff about the differences between your local data center and Windows Azure that you should think about to make this thing fault resilient, a bit built for scale, built for failure, and things like that. So we're going to look into that. First, we're going to design this application for failure. Assume everything will fail. That's a ground rule if you're starting to work with Windows Azure. An update may occur. That's technically not a failure. They are just updating your VM. But if your application is running a process on that server that's being updated, the process will be killed. So for your application, that's in fact a failure. So think about the fact that there will be updates, that maintenance will occur, that Windows Azure may move your VM from one rack to another. There's a small downtime in there. Prepare for that kind of failures. Prepare for crashes. Windows is pretty stable, but your application code may have an unhandled exception, which kills your VM. Think about that. Make sure you build your application to handle such cases where your VM crashes, or Windows crashes, or something may happen on the compute node where the VM node just goes down. I told you that Windows Azure monitors itself, and it tries to do the best for Windows Azure, but not necessarily for your application. Which implies on storage and on SQL Azure, you can have throttling. Just to explain, if you hammer SQL Azure with, I think, more than 30 connections per second, Windows Azure will start slowing you down. Reason for that is they want SQL Azure to survive, and your application will suffer from that. So you have to take into account that SQL Azure may go slower, or that the storage may throttle you and deny access for several requests. Make sure you can handle those situations. Connectivity is another one. If something fails in the data center, for example, a network connection crashes or a switch crashes, your VMs are still running, and they may still be able to access storage, but they may not be able to access different services out there. So you have to have some queuing mechanism or something to cope with that kind of situations where you cannot access services that your application requires. And of course, your code may fail. I think that will be the part that fails the most on Windows Azure. But your code will fail, it may fail. Think about how you're going to handle specific crashes in your application. About the throttling, this is an exception that you may get when using SQL Azure. The service is currently busy, retry the request after 10 seconds. Which means if you have a lot of requests coming on your website which uses SQL Azure may throw this exception and just deny new connections for 10 seconds or for up to 10 seconds, which is not very nice. And most applications will just say, okay, connection failed, exception, error page, right? On Windows Azure, that may not be the best solution. You may want to retry. This is not really a failure. It's just SQL Azure denying you access, which is not a failure. What you can do is just read the message and have your code respond to it. Let your code wait for 10 seconds and try again. And maybe it will work the second time, or the third time, or the fourth time. And if, for example, after 10 times it still doesn't work, then throw the failure at your user. But just retry a few times. You can write that yourself, but the Patterns and Practices team has also created the transient fault handling framework, which you can find on that URL, which will do those things for you. So if you have an exception, that framework will make sure some stuff is retried a couple of times, both on storage and on SQL Azure. Now, what if the entire data center fails? Which may happen. I know Amazon had a great outage somewhere September last year, I think, where half of the internet apparently seemed to be hosted on Amazon. They had an entire data center fail for, I think, almost 3 days. So that's a problem if you're running a commercial application on there. Windows Azure also has problems. Last week, they also had a small outage in one of their data centers. It can happen. Cloud is built for failure. They try to cope with as many failures as possible, but it can still happen. So make sure you do something about it. Make sure your application can survive situations where the entire data center crashes. Run on multiple data centers and keep your data synchronized. Of course, you have to think about the fact, will you synchronize all your data or just specific tables or specific data? You can think about that. Eventually, something happens like this. You can have your application still running in a degraded mode, where some data is not available, for example, but your application can still be running. Let's refactor our architecture, and let's run on 2 data centers. For example, Windows Azure has North Europe and West Europe. You can run in both data centers. Just copy the same architecture in both data centers, which means in every data center you will have Windows Azure's load balancer, you will have some VMs, and you will have an instance of SQL Azure running. There's the Windows Azure Traffic Manager, which is an interesting tool that uses DNS for distributing traffic between both data centers. So what you can do is instruct the traffic manager, for example, to fail over from one data center to another if something happens. Maybe a solution. You can also round robin between 2 data centers, which may be more interesting because you have 2 data centers running. Maybe you want to instruct traffic manager to just use those 2 data centers. I think it's a bit stupid to have 2 data centers and just use one. Maybe you want to instruct traffic manager to just load balance across both data centers. Of course, you have 2 storage instances of your SQL Azure. Luckily, there's also SQL Azure Data Sync, which enables you to communicate between those 2 SQL Azure instances and keep them in sync. Again, either all tables or some tables. You can decide for your application. Those are the data centers that are available. So what you can do is, for example, run 2 instances of this application in 2 data centers in Europe. Or one in the US, one in Europe, and synchronize between those, which is again a use for traffic manager. You can have your application sitting in Europe in one of the data centers, and you will see if someone requests something from that website, latency will get higher every time some user is further from the data center. So if you go to South Africa, for example, your server sitting in Europe will be pretty slow. Nothing you can do about that, because that's just the speed of light, the speed of the network connections between two continents, for example. And of course, the further you go from the data center, the longer it will take to access your data. So if you're running in 2 data centers, maybe it's an option to run 2 data centers in 2 continents. If you're a newspaper website, like our example, for example, you can have a data center in Europe and one in the US or one in Asia. Reason for that is, it's built for failure. You still have 2 data centers between which you load balance. But also, if you have international users, for example, a lot of Finnish people living in the US or in Asia or something, you can have them redirected to a local version that's in a data center nearer to them, which means you actually are designing both for scale and for speed and for failure. Because if one data center fails, they will go to the other, which will be slower, of course, but there's still 2 data centers. Again, something Traffic Manager can help you building. Actually, Traffic Manager has 3 strategies that you can instruct it to use. One is round robin. Just one request goes there, next request goes there. One request goes there, next request goes there. There's also a failover mode, where you can instruct Traffic Manager to use one data center by default. And if that does not respond, for example, switch to the second one, or to the third one, or the fourth one. And there's the performance setting, which will just distribute traffic according to where your users are coming from. So users from the US will go to a US data center, Europe will go to a European data center. Solves speed and solves the fact when a data center fails. Or when a ship throws out their anchor and they pull a cable from the seabed. Can happen as well. Again, a solution to overcome this kind of problems. So, are we there yet? We have our application running in 2 data centers, either both in Europe or both in a different continent or a different data center. But I don't think we're there yet. What if, actually you have 2 deployments of your application, what if one of your SQL Azure databases fails? How are you going to handle that? Solution there may be set up a monitoring endpoint for Traffic Manager. So what you can do is create one specific page in your application which monitors your SQL connection and which gives either a HTTP 200 status or an HTTP 500 status, so success or failed. And you can register that in Traffic Manager. So you have a setting there where you can specify a specific page that it should monitor, and Traffic Manager can change its policy based on that one. Which means if some SQL Azure server fails, by using this technique you can instruct Traffic Manager to just fail over to the other data center, which is an interesting solution. Now, that's an interesting solution, but the moment SQL Azure is down, you still have 2 data centers running at full speed, maybe 10 VMs in every data center, which costs a lot. And you're basically redirecting all traffic to the other data center while those 10 machines that can't connect to SQL Azure there are unable to do their work and they are just sitting there idle. So maybe a better idea, of course this is a good idea, it may work for your application, but maybe a better idea may be to take out the single point of failure that is SQL Azure. Make sure you have 2 SQL Azures running in that data center. Make sure you distribute your data over multiple databases in there. And if you do something like that, you can degrade gracefully. For example, what you can do is, say you are this newspaper website, you can store all your articles in 2 databases. One contains all articles that are written before lunch. The other one can contain all the articles written after lunch. If a failure happens in that case, so for example, when one of the SQL Azure servers goes down, okay, you lose some data that is not available at this moment, but you still have a lot of stuff running. There's still articles available, there's still data available in the other database. Not all data, but you still have 2 data centers running and you're just a bit degraded for some users. You're still running, up and running. Next thing we're going to do is design for scale. So we've designed for failure up till now. So we made sure that some things may happen. A data center outage, SQL Azure may be down, a virtual machine may be down. Next thing we're going to do is build for scale. What if, for some reason, there's a lot of people coming to your website, coming to your application, and you want to prepare for that? Now, small side note, if you design for scale, you will probably also be designing for failure more. Which means if you add more servers, of course you will be designing for failure as well, because you have more servers running your application, and there may be a higher number of servers going down before your application actually fails. So both have a tight connection. Here's an interesting one. We Belgians are not that used to snow. That's the Flemish part. All the lines on there are all our motorways. And this is 1 centimeter of snow. That's 40 kilometers. So basically that was one day this year where we had a lot of people visiting this website, making sure they would be able to make it home through that 1 centimeter of snow. Now the problem there is this site went down because of that. 1 centimeter of snow, site goes down. So how do you prepare for that? Well, design for scaling and design for failure, of course. So what happens if that was our website? What happens if a lot of people come to our website? This will happen. The VMs will crash. There's just not enough server capacity for making sure all our users can go to these servers. So these servers will probably crash or start rebooting or start to hang or will be slow. That layer of your infrastructure, of your application, will go down or will have problems. So how do you solve that? Scale out, add more VMs. Now, unfortunately, Windows Azure doesn't do this for us. For a good reason, because that would mean Microsoft is actually making you pay more, while you may want to have a spending limit or something. So you have to do it yourself. Luckily, there's a monitoring API, you have diagnostics, so you have all the tools available to auto-scale your application if you really, really need it. One way to do that is use the Wasabi block, which is available on NuGet. It's an enterprise library block which you can instruct to monitor CPU usage, memory usage, number of storage transactions, all that stuff. And you can configure some rules. For example, if CPU usage is above 90% for 5 minutes, scale up or scale out. Another solution, if you don't want to develop it yourself, is use something like Opstera. They actually have a service doing auto-scaling for you. Of course, it costs. Of course, you don't have to write your own code. But you can use something like this as well to make your application scale automatically when needed. So here's what will happen. Again, we have 1 centimeter of snow. A lot of people are coming to our website. Auto-scaling kicks in. A number of servers come in there. Next thing that will happen is this. Okay, we have a lot of more servers where users can come in. But remember when I told you SQL Azure will start throttling you at around 30 connections per second? That's what will happen. SQL Azure will refuse new connections because of the fact that there's such a large number of VMs connecting to the SQL Azure databases. So you have to take into account that this can happen. Of course, I told you about the retrying and just retry connecting. But in this case, that technique will make it worse, in fact. Because you will be denied a connection, server will try again and again and again and again, and SQL Azure will just refuse any new connections until the load goes down. So SQL Azure is monitored by the platform itself, and the platform tries to keep the platform healthy. So they will start throttling, and they will not like high database traffic like in our situation that we just had. So we have to introduce some caching in our application. Since our website is, well, most of our website is just reads for articles, for newspapers, for blog comments, stuff like that, we can easily cache most of our data in a caching layer and have all reads coming from this caching layer and just reduce the load on SQL Azure that's sitting underneath. Now what you can do for caching is do a lot of things. You can run memcached on your VMs and cache in there. You can use Windows Azure's caching block, no problem, will work. Or you can use blob storage. Okay, that's storage, okay, that's a blob, but if you name every file on blob storage, for example, with the ID of your article that you are requesting, you can just request the data from blob storage. Should not be that slow. It's probably around the same time in latency as the Windows Azure caching, because it's all over HTTP. It will be fast. So you can decide. One word of warning, Windows Azure caching, I think it's insane that they have it, but Windows Azure caching in fact also does throttling. Which means if you have a really, really high loads on your website and you use caching, the caching layer may also start throttling you. So maybe it's better to move to blob storage or some other component just to make sure you can handle really, really high loads. Of course, most applications will have more than enough capacity in the Windows Azure caching block, but just wanted to warn you, if you're building a really large thing, maybe it's best to have a different strategy around caching. So let's refactor our architecture. Let's add some caching. And I made the block across both data centers. You can do that, but you can also introduce one caching layer for every data center. You can decide on that. It's probably better to have one caching layer in every data center. Reason for that is it will be easier to overcome all the throttling that is happening in there. So it will be much easier to handle throttling from the caching and everything that's happening in there. Problem with caching is, how do you populate it? How do you make sure that all data is in the cache whenever you need it? When do you populate it? When your application is starting? Or the first time a user requests some data? If you populate it the first time a user requests some data, it may be slow because you have to go to your database again. If you pre-populate it, you may have the risk that the cache is stale. If you, when the application starts, for example, and you add some data to the caching layer, what will happen is if a user requests data from the caching layer, that data may be outdated. If it's already in there for 1 or 2 hours, maybe there's been an update to the newspaper article and you don't have the updates displaying on the website. When do you invalidate it? When do you make sure the cache gets refreshed with fresh data from the database? Again, at application starts, every 5 minutes, every 10 minutes, or every time a new user enters? I don't know. It depends on the type of application that you're building and on which application you're building. You can work asynchronously. That's probably the best solution on Windows Azure. One strategy for caching could be whenever a user enters and the data is not in the cache, read it from the database and immediately add it to the cache. Maybe a good strategy. Problem is that if you have multiple machines doing this, the database will still get hit by every machine to read that one entry and add it to the cache. If you have 1,000 servers accessing this database just to update one item in your cache, again, SQL Azure will not like that, and they will start throttling you. So a better technique there may be just read from cache. If no data is available in the cache, just push a message on some queue somewhere. Tell someone else to fill the cache for me. Okay, your user will not get data immediately. You still have to wait for the cache to be populated. But again, if you have 1,000 servers, all those thousands will instruct one server, for example, to update the cache. And only one server will go to your database, which will be much healthier for using SQL Azure. So here's what you can do there. Your VM will check in the cache layer. Is this data available? Is this article available? If not, it will instruct the cache or read it from the database or do both. But you typically will just push a message on some queue somewhere telling, hey, I want this article updated in my cache. Per data center, across all data centers, whatever you want, but just have a queue where you instruct something to update the cache. That queue can be read by one worker or 2 workers or a set of worker roles sitting in the back, just processing this queue for all incoming commands. And what they will do is read data from the database, of course, first read a message from the queue that they should update the cache, then read it from the database and insert it into the cache. Next time a user comes to our website, the cache will be present and they can just read it from cache immediately, which is an interesting technique. Now, one side note, why do I have the queue there? Reason for that, again, is design for failure and design for scalability. Design for failure. If my set of worker roles processing this queue and updating my cache, if they all fail, no problem. My site will be slow, my site will be degraded, but I still have all my messages sitting in this queue, and whenever a worker comes up, it will start populating my cache again. So I can work asynchronously, my workers can crash, some failure may happen in 1 or 2 data centers, but my cache will eventually get updated again. Another reason for this is if I have a set of workers and I would use synchronous communication where my web form would just send off a WCF request to this worker telling it to update my cache, for example. What will happen is if again I have 1,000 servers and I have one server dedicated for updating the cache, that one server will go down. Why? Because suddenly I have 1,000 servers connecting to that server requesting for cache updates. That one server will probably not be able to handle those thousands of requests coming in. So again, designing for scale and for failure, and just making sure there's a queue and my worker can read the queue at its own pace. Not be hammered by all kinds of connections coming from the other servers in my data center. So again, 2 reasons why I do this architecture. Now, a typical web request, if you go to Microsoft.com, for example, you should try this using Chrome and look at what is actually loading. And you will see that there is, I don't know if you can see it, my default.aspx is basically the page that is being requested. All the other requests are static data, images, CSS, JavaScript, stuff like that. If I look at my screenshot, I have one request to a dynamic page, the home page of Microsoft.com, and over 400 requests going to static data, which is kind of interesting because your servers will have to process all that static content. If I request the Microsoft logo, for example, my servers will have to read the Microsoft logo from their disk, serve it to my clients. Even though it's static content, my servers will require some processing to just serve the image, serve the CSS file, serve the JavaScript file to my user, which may not be interesting. So get that static content out of your virtual machines. Put it on a storage account, put it on the content delivery network, somewhere else. Just make sure that your servers only have to be occupied with dynamic data. Dynamic requests actually requiring some processing to happen to server requests. There's no use of having 1,000 servers serving images. Azure has this content delivery network, Azure has this blob storage, just push it over there. Okay, you have to change your HTML to link to those images hosted on there, but your servers will have much more processing power available to do this. Also, cache content near where you need it. Again, if you have the Microsoft logo and you have a few thousand users requesting that every time, it may be intelligent. Whenever they go to a different page on Microsoft, there's a chance that they request the image again. Make sure you cache near where it's needed. So one step there can be move it to the content delivery network, which will ideally be in a data center that's nearer to the user. The user will have a faster experience, and you're offloading some processing to a different service on Azure. Another interesting place to cache this may be on the user. Make sure you set your cache control headers. Make sure that if someone requests a CSS file, that they have it in their browser cache the next time they do a request. You will have fewer requests on your VMs, fewer requests on your content delivery network. The user will have a faster experience, and because of all of that, you will pay less to Microsoft for hosting all these things. So that's a giant win if you do something like that. So the CDN There's a lot of, I think the latest number is 26 data centers around the globe where you can push your data. So if you have images, if you have CSS, if you have JavaScript files, just push them on the CDN and serve them from there. So our architecture will look different. We have this thing, but next to our VMs, we also use the Azure CDN to host some images, static content. Now, an interesting side note here is, I told you to cache near the user. I have a fun example. We had for a telecom operator in Belgium, they had a website, a campaign website, where you could select well, some free prepaid minutes, some free text messages, some free data traffic. You could make one choice. Now the idea there was a user could only make one choice per cell phone number. So how would you build that? One approach could be every time a user selects something and says, okay, I want this offer, go to your database and check if he has already ordered something. That's one option. Will fail because you will have a lot of requests going to your database. Another option is use the caching layer. Store the fact that a user has selected something previously in the cache and read it from there. Okay, imagine 3 million users going to this application. Either the cache will start throttling or you will still have a lot of reads going to your database. Cache near your user, and the nearest place to cache something is on the user's machine. So what we did there to cope with this load was actually just store a cookie with his cell phone number on his machine. And we just used that cookie to determine if he's already ordered something or not. If the cookie wasn't present, of course we had to go to the database. But if the cookie was present, we could just skip reading from our database and not have to do any, well, not a lot of server-side processing at all. So cache near your user. Use cookies, use the browser cache. Try to cache as close to your user as you can. It will be cheaper, less CPU involved, less database transaction involved, and much faster for the user. So, as a conclusion, the cloud is different. We've seen if you take a traditional application and you want to build something like that on Windows Azure, it will work, no problem. Do know that because the cloud is different, because SQL Azure starts throttling, because monitoring is different, because the actual outcome of how the data center is operated is different, that approach will probably also fail. So make sure you think about how you can structure your application, how you can overcome the fact that a data center goes down, or a server goes down, or the database goes down, or something like that. Design for failure on every level. Azure will fail, your code will fail, compute nodes will fail, Windows updates will fail, everything can fail. Always keep that in mind. Also design for scale. Make sure that if sudden peaks on your application are coming in, make sure you have enough capacity. And if you have enough capacity on all layers. So if you add 1,000 VMs, but you still have only one SQL Azure database, SQL Azure will just die. So that's no use in designing for scale. You also have to scale out SQL Azure there. Try to work asynchronously all the time. I gave you the example with the queue to update our cache. What you can also do if you have some user data, for example, you can also always read from cache and put on a queue the fact that the data has to be updated or refreshed or something like that. Work asynchronously. Your backend may go down, no problem. All the items will still be in the queue. And at some point in time, they will be processed. Also, if you have a lot of servers communicating with that backend, the backend will probably die, so work asynchronously. Use the queuing that's available in Windows Azure. Cache close to where it's needed. Use the CDN, for example. Cache in the caching layer, cache on blob storage, no problem. But also make sure you use all the stuff that's available for caching on the client itself. Set your cache control headers, make sure the browser doesn't request the same file over and over. There's no use in that, just keep it on the machine. Store some data in a cookie or somewhere on the local machine of the user. If that benefits your application, of course you can't store all user data in a cookie, that will probably not work, but store some data in there. Make sure you don't have to go to your database every time a request comes in. Also, in this talk, I went a bit over the edge, I think. If you have a typical application running on 2 VMs, you will probably not scale out to multiple data centers. You will probably not scale out to multiple SQL Azure databases just because of the price. So always try to find a balance between how scalable and how fault tolerant should it be versus what will I have to pay. If your application is used by 2 users and there's no problem in being down for a few hours, don't use my talk. If you're building a website that a lot of users will be using that really has to have a very, very high uptime and should be available all the time and should scale to millions of users, maybe it's interesting to consider something like this. So always think about the price versus how long can I afford to be down. Also, learn from others. There's a lot of good stories on the internet how some people build their websites. Amazon, for example, they have a slide deck on SlideShare, which also covers how you can build your application for fault tolerance, for a lot of users, for scalability, stuff like that. Trello, also very interesting case. Actually, that website is doing everything in their cache. They only have a database as a backup if the cache fails. So what they do, for example, is every write goes to the cache, and of course they persist it to the database as well, but all reads come from cache, and only when the cache fails, they try to repopulate the caching layer. So an interesting one to read. Another interesting one, okay, I know it's probably not suitable for work, but that's typically the website that has a huge amount of traffic, and that relies on income from the website, so they probably will not like downtime. So also that's an interesting story how they built their architecture. Same with Stack Overflow. You probably know Stack Overflow. The website stackoverflow.com, how many servers do you think? Stackoverflow.com, not the entire Stack Exchange network, but just stackoverflow.com runs on 6 servers. Why? Because they have a very interesting architecture regarding caching and database setup. Instagram, and there's a lot more of these stories on highscalability.com, so very interesting reads to check how you can build your application and make sure you're ready for both failure and for scale. With that, I know I stopped a bit early, but if you have any questions, feel free to ask. No questions? Okay, in that case, I thank you for being here, and I'm going to rush to the airport. Thanks.